Dear students, welcome to today's class. In the last few classes, I explained about what is a function, what is a rule of a function, and what is the domain, codomain and range of a function, and how to find out the domain of a function for various types of functions we have seen. Okay, now in this class, I am going to explain the types of functions. So, various types of functions, particularly there is a one function or injection, and a many one function, onto function, into function, one onto function, inverse function, constant function, identity function, even function, odd function. Generally, if you see the whatever maybe the materials what you have, so you will get the definitions of this. But I am trying to explain these functions in a different way. Maximum I will go for graphical approach. Okay, na? So let us start our class. Let us see the first function, that is one function. It is a very clear. It is a very clear one function. Generally, where we observe this one type of function. For example, if you are traveling in a bus, in the bus, every passenger will be given one ticket. Every passenger will be given one ticket. That means one passenger, one ticket. One passenger, it will be one ticket will be issued. Is two passengers will be given one ticket? No. Is two passengers will be given one ticket? If you ask, sir, for both of us, give one ticket? No, they won't give. That means one passenger, one ticket will be given in any bus or any train or any flight. Okay. Is one passenger will get two tickets? Is one passenger can get two tickets? No, you cannot get. One passenger have to get only one ticket. Why? Because for him only one seat will be reserved. One passenger cannot reserve two seats. That means one ticket for one passenger. It is a clearly a one function. In our school attendance also, one natural number will be allotted for one student, roll numbers. One student, one number, one student, one number, one student, one number, or one number to one student. Understand? Is two students will be given same roll number? No. Is one student will be given two roll numbers? No. So these are the various examples that we come across in one function. That means one element, one image. So this type of functions are called one function. Okay, now right. So let us see that in Venn diagram wise, A, B, light F. F is a function from A to B. Let us take the elements 1, 2, 3, 4. Here 5, 6, 7, 8, 9, 10. 1 is mapped onto 5. 2 is mapped onto 6. 3 is mapped onto 7. 4 is mapped onto 8. So it is a clearly a one function. That means no two elements will have the same image. Okay, now. So if you see the notation wise, F. So if your element is x1, your image is f of x1. If your element is x2, which is in the domain, your image is f of x2. Okay, now that means no two elements will have the same image. That means x1 is equal to x2 implies f of x1 is equal to f of x2. So two elements different, two images also different. Okay, now otherwise you can prove like this also. So f of x1 is equal to f of x2. Take f of x1 is equal to f of x2. You solve that equation, whatever may be the equation you will get, solve it. You will get, if you get x1 is equal to x2, if you get x1 is equal to x2, then that function is a one function clearly. And that means no two elements will have the same image. That means what? This type of functions are not allowed. This is x1, x2, this is f of x. No, x1 is the image f of x, x2 has the image f of x. So this type of functions are not one functions. Okay, one element, one image. Okay, right. Now I am going to explain, given a function, if it is a function is there, for example, any function is there, f of x is equal to 2x plus 3, f of x is equal to x square plus 2x plus 3, f of x is equal to mod x. f of x is equal to e power x, if f of x is equal to a power x, whatever may be that, e power x, a power x, sin x, cos x, otherwise 2x plus 3 is given, it is given. So without doing all these things, if it is using graph, how to say that function is a 1-1 function. So if you approach graphically, the problem will be very, very easy one. Okay, na? So let us see the graphical approach. Now I am going to explain how to say a given function, how to conclude that a given function is a 1-1 function using a graphical. Okay. So for example, whatever may be the graph you draw the function, draw a line, horizontal line with the x-axis. That line should intersect the graph at most one point. Intersects the curve. This curve may be sin x curve, cos x curve, 2x plus 3 by x square plus 2x plus 3, whatever may be that f of x curve will be given, no? This you know how to draw the curve, sin x, cos x, whatever may be that. You draw the curve, draw a line parallel to x-axis, whether it is above the x-axis or below the x-axis. The line should intersect the graph at most one point only. Then only we say that that function is a 1-1 function. Okay, now, so let me give one example. Let us check whether this function f of x is equal to x square and f of x is equal to x cube, both are 1-1 functions or not. Yes, obviously this is not a 1-1 function, this is a 1-1 function. Clearly anybody can say that. Why? So if you substitute 1 square 1 is the image of 1. Substitute minus 1, also again you will get 1, that is 1 is the image of minus 1 also. That means both 1 and minus 1 will have the same image 1. Therefore it is not a 1-1 function. That you can conclude, no problem, you can conclude. But how to say that the function without all those type of calculations, without doing that, how to conclude that the function is a 1-1 function. Okay, now let us draw the graph. Okay, x-axis, y-axis. You know that f of x is equal to x square means y is equal to x square. Y is equal to x square is a parabola passing through the origin, lies entirely in first and second quadrants, and it extends indefinitely in the upward, open upward, right? Now let us draw a line parallel to x-axis, anywhere. So draw it. So you see here, is it intersecting x-axis at 2 points? Yes, it is intersecting at 2 points. Therefore, it is not a 1 function. What is the theoretical support for this means? So here x, what is your here? F of x. Your image is f of x. Observe here, it is a minus x. For this is also image is f of x. For x, image is f of x. For minus x is also image f of x. That means for x and f minus x both have the same image. Therefore, it is not a 1-1 function. Clearly. Then how to check whether the given function f of x is equal to x cube is a 1-1 or not? For that also draw the graph. Y-axis, x-axis, origin. As you know the graph of x cube graph, as it will be like this. So this will be the graph. That is y is equal to x cube graph. That means it lies in the first and third quadrants, and as x value increases and y value increases plus infinity. As x value also decreases and y value also tends to minus infinity. Okay, na? Right. So this is the nature of the graph. Now draw a line parallel to x-axis. As see here, intersects x at only one point. Any line draw parallel to x-axis, See here, it intersects at only one point or not? Here only one point or not? Yes, clearly we say that the function is a 1-1 function. This is called horizontal test. Whatever may be the graph you draw, then if you draw the line parallel to x-axis, then we say that if it intersects the graph at most one point, maximum one point only, then we say that that function is a 1-1 function. Okay. So let us check sine curves and sine function and cos function, they are 1-1 or not. Okay, now So let us check the function f of x is equal to sin x is a 1 function or not. Y is equal to tan x is a function is a 1 or not. So see here, I am not given domain here. I am not given domain. Let us say the domain of this function is R, set of real numbers. Okay. So let me draw the graph of this y is equal to sin x. So this is x axis and y axis. You know that this is a pi by 2 and pi. This is a 3 pi by 2 and it is 2 pi. And this side minus pi by 2 minus pi. This is a minus 3 pi by 2, this is minus 2 pi, 0, this is 1, this is a minus 1. You know the curve, sine 0 is 0, this is a pi and it is a 3 pi by 2. So this is a minus pi by 2, minus 3 pi by 2, 2 pi. So this is the sine curve. This is a sine curve, you know clearly. This is a clearly, if your function domain is from R to R, it is clearly, it is not a 1 function. Clearly, why? The line parallel to x-axis intersecting the curve more than 1 point. Therefore, it is clearly, it is not a 1 function. Okay. Then how to make in which interval it is a 1 function? If you observe here, if I take here minus pi by 2 to plus pi by 2. If I restrict the domain minus pi by 2 to plus pi by 2. Observe here, from here to here the curve is minus pi by 2 to plus pi by 2. Up to here you see, observe. So I have restricted the domain. So this is a very, very important concept which you will come across in inverse trigonometric function. So what I have told you, so total domain is set of real numbers. Total domain is set of real numbers. So for that real domain real numbers, I cut short. I cut it here plus pi by 2, here also minus pi by 2. I have reduced this. Okay, I will draw this. I will remove this, all these things. So from minus pi by 2 plus pi by 2, you draw a line, horizontal line. So here, see here, see here, see here. So it intersects the curve at only 1 point. So if the interval is from minus pi by 2 to plus pi 2, and your range is obviously minus 1 to 1. So it is your function f of x is equal to sin x. Yes, it is a 1 function. If you have taken the domain minus pi by 2 plus pi by 2, of course range is minus 1 to 1. So in this interval minus pi by 2 to plus pi by 2, the function is a 1 function. So if anybody asks you, sin x function is a 1 function or not, you immediately you have to question. What the question you have to, sir, what is the domain? What is the domain? If domain is R, it is not a 1 function. If the domain is from minus pi by 2 to plus pi by 2, okay, then it is a not only minus pi by 2 to plus pi by 2, again pi by 2 to 3 pi by 2, again pi by 2 to 3 pi by 2. If you observe here, it will come, no? So this is a pi and it is 3 pi by 2. Same again pi by 2 to 3 pi by 2. So pi by 2 to 3 pi by 2. Again it is a 1 function. Again 3 pi by 2 to plus 5 pi by 2. So from this what the conclusion you will get means, if you restrict the domain, if you cut the domain in both the way, in both the direction, then the function will be, the curve will be a 1 function. Okay. Similarly we will see the tan x graph also. So here also let us draw the tan x graph. So this is equal to x-axis, y-axis 0, this is a pi by 2, this is pi, again 3 pi by 2, this is 2 pi. This side minus pi by 2, minus pi, minus 3 pi by 2, minus 2 pi. Okay, now as you know that tan x is undefined with the odd multiples of pi by 2. So this is pi by 2, this is a 3 pi by 2, this is a minus pi by 2, and this is a minus pi by 2, minus 3 pi by 2. As your graph is tan 0 is 0, this is a 3 pi by 2. Okay, right. So this is your tan x graph. Obviously, if you take the domain is set of real numbers if you take, so it intersects the graph more than once. Clearly, it is not a 1 function. Okay, now then how to make it is a 1 1 function? The only thing is cutting the domain in the both the direction. Whatever may be the domain, in this domain we required, you cut it. So clearly if you cut the domain from minus pi by 2 to plus pi by 2, minus pi by 2 to plus pi by 2, same just like tan function, it is a 1 1 function. That means what? So I am rubbing this. See here, minus pi by 2 to plus pi by 2, up to here only you see here. So it intersects the, if you draw the horizontal line, it intersects the graph at only one point. So therefore, the function y is equal to tan x is minus pi by 2 to plus pi by 2, set of real numbers, range is set of real numbers. So f of x is equal to tan x is a 1 1 function. Understand this? So first of all, you have to draw the graph of the function. So similarly, e power x, a power x, log x, all are 1 1 functions. E power x, a power x, log x. You draw the curves, observe the curves. So all are 1 1 functions. Okay, na? So this is called horizontal test. Okay. So I hope that you understand this horizontal test. So let us go for next problem, that is many to one function. Dear students, let us see the second type of function, that is a many to one function. So it is a quite opposite of 1 1 function. The name suggests many to one function. Okay, right. So this is a very easy one. So a, b, let us say 1 2 3 4 5 6 7 8 9. 1 is mapped on to 5, 2 is mapped on to 6, 3 is mapped on to 7, 4 is also mapped on to 7. Then it is clearly a many to one function. Completely opposite of 1 1 function. If a function is not 1 1, then obviously it is a many to one function. Okay, now, right. Then graphically, how to say that it is a many to one function? Just what I said just now only, it is the opposite of 1 1 function. That means what? For example, if you take f of x is equal to x square graph, f of x is equal to x square graph. So if you see the horizontal line test, that means if you draw the line horizontally with respect to x-axis, so therefore it intersects the graph at 2 points, therefore it is a many to one function. That means what? The horizontal should intersect the graph at more than 1 point. If more than 1 point it intersects, then it is a many to one function. Okay, now, right. Generally, if you take the set of real numbers to real number, the function is f of x is equal to sine x. If it does not restrict the domain R, then it is a many to one function. Okay, now, why? Because for sine 0, you are getting 0. For sine pi, you are getting 0. Sine 2 pi, you are getting 0. So that means pi, 2 pi, 3 pi, n pi, for all that you are getting 0. That's why it is a many to one function. If you restrict the domain, you can make it into 1 1 function. Okay, now it is a quite opposite of 1 1 function. Okay, so draw the graph, draw a line parallel to x-axis. If it intersects the x-axis at only 1 point, then it is a at most 1 point, that is a 1 1 function. Otherwise, it is a many to one function. Okay, now, right. So I hope that you understand this concept. So let us go for onto function. Dear students, I am going to explain both one onto function and into function. Why? Because a function, if it is a onto function, then it cannot be an into function. If a function is not a onto function, then it is called a into function. Just they are quite opposite. So what is a onto function is a very easy one. So let us take this two non-empty sets A and B. F is a function 1 2 3 4 5 6 7 8. So 1 is mapped onto 5, 2 is mapped onto 3, 3 is mapped onto 2, 4 is mapped onto 7. So here if it is a, observe here, every element of A is mapped onto unique element of B, therefore it is an onto function. If you observe, every element of codomain is the image of at least one element of A. Every element of codomain is the image of at least one element of domain. Then it is called onto function. From this, what can you say? What is the codomain here? What is the codomain? the set of elements 5 comma 6 comma 7. What is a range here? That is also 5 comma 6 comma 7. So if codomain is equal to range, then it is an onto function. Otherwise, if at least one element is left over here, for example 8 is there, then it is an into function. Understand? Onto, into. Very easy. If any vacancy is there, it is called into function. It is no vacancy is there, onto function. For example, you are traveling in a bus. There is a full of bus is coming. You are waiting for a bus. Bus is full. There are no seats available. Then what the conductor will say? He will say go and stand in the top. That means onto function. If it is a full, if there is a seats are available, one seat is available 8, then is asked to come into the bus. That is into function. So there is no seat is available onto function. Go and stand top of the bus. You travel in the top of the bus, onto function. If is there any empty space is there in the bus, then come into, therefore it is an into function. If the seat is available, into, seat is not available, onto, go on to. Okay. So this, if the codomain is a range, then it is an into function. So this is a onto function. If it is a range is strictly subject of codomain. If it is range is strictly subset of codomain, then it is into function. Into function. If it is a proper subset, then it is an into function. Okay, now we are going to see, given a function, how to check without graph how to check whether it is a into function or not. What is a working rule? For that working rule is this: a, b, f is a function. Your element is x, your image is f of x. That is a notations. Okay, I already told you about the notations. This is a working rule without graph. How to check whether it is a onto function or into function. First of all, what is a onto function? What is onto function? For every element of codomain, is the image of at least one element of domain. That means what? For every y, you have to find out one pre-image. For example, if it is a y is equal to some 2x plus 3, therefore 2x plus 3 is equal to y, x is equal to y minus 3 by 2. Then your what is a x? Then you have to check for every element y, you are getting x or not. For every element, you substitute here, y is a real number. Any number you substitute, you will get a number. You substitute 0, 0 minus 3 to 0, 0. Again you substitute 1, 2, 3, 4. Tell me any one number for any y value for which you are not getting x value. No, for all y values, for all real numbers of y, you will be get x. Therefore, it is an onto function. So first of all, to find the onto function, let us take that image, condition of the image 2x plus 3 is equal to y. Then write it as a subject of x. Then check for any number it fails. For a y value, for any y value it fails. Okay. If you check it, the problem will be over. This is a working rule for to find the function is onto. If you failed it, then it is an into function. Okay, it is an into function. Now, our topic is now how to check a given function is onto or into using graph. Okay, na? So let us proceed further. Let us see that there are two functions are here. Of course, both functions are same, defined as same, but their domains and codomains. Let us see the domain. For here, the first function domain is set of real numbers. Codomain is set of numbers from 0 to infinity. That means 0 and positive real numbers. Okay, now for the second function, it is a domain is also real numbers, codomain is also real numbers. Let us check which function is onto function and which is not onto function using graphically. Okay. First, I will draw the graph of the modulus function. Right. We know that modulus graph is this. and x-axis, y-axis. As mod x is always either 0 or positive, this will be your graph. This will be your graph. Y is equal to mod x graph. This is y is equal to mod x. Now, to check whether it is a onto function or into function, you have to take one point, any point from the codomain. From the codomain. What is the codomain here? 0 to infinity, positive infinity. That means what? Codomain means y values. So, from here to here, here to here means this positive y-axis, positive y-axis, positive y-axis. Okay. Now, take any number you like, from any number from 0 to infinity. Let us take 2, 3, 4. Draw a horizontal line. Draw a horizontal line. Understand? See here, is it intersects the x-axis at one point or 2 points? See here, it is intersects the x-axis at 1 point or 2 point. Yes, it intersects the x-axis at more than 1 point. Therefore, this is onto function. This is onto function. How can you say that onto function? Very easy. For every x value, you are getting y value. For every x, you are getting y. For every x, you are getting y. That means for every y value, you are getting x value. For every y value, you are getting x value. For every y value, you are getting x value here. For every y value, you are getting x value here. That's all. Therefore, it is an onto function. That means you have to draw a line taking a point from codomain. Be careful that. You are not simply drawing a line horizontal. Otherwise, you can draw the line here. No. You have to take any point from the codomain, and draw a line. That line should intersect the graph at more than 1 point. If it intersects the graph at more than 1 point, then that graph is represents onto function. Okay, na? So clearly it is an onto function. That means for every y value you are getting one x value. For every y value you are getting one x value. It is an onto function. Let us check for that. Let us check for that. Right. So here also I am drawing the same graph. Y is equal to mod x. So this is equal to y is equal to mod x graph. Here, what is the codomain here? Set of real numbers. Codomain means y-axis. Y-axis. This is set of real numbers. So here I am taking number. I can take any number, -2, -3, whatever. Draw a line. Is it intersecting the graph? No, not at all. It is intersecting. That means it is into function. It is into function. If it intersects more than once, then it is an onto function. If it is not onto function, automatically it is an into function. But the thing is, you have to take a point from codomain, not domain, codomain, y value. So this is a y value. Okay, here y value. Y value. That means for this y value, there is no x value. If you have y value, so you have x value here. Here one x value you are getting, here one. For this y, you are getting one pre-image here, one pre-image here. If it is a -2, you are not getting any pre-image. You are not getting any pre-image. You are not getting any pre-image. That's why. That means my -2 is empty. -2 is empty. Therefore, it is into function. Come inside. -2c it is empty. Therefore, come inside the bus. Into function. Here, for every y, positive only. For everything you are getting x value. For everything you are getting x value. So understand this. Okay. For onto function or into function, so you draw the graph, whatever may be that. First you draw the graph. Y is equal to mod x, y is equal to e power x, y is equal to a power x, sin x, cos x, tan x, whatever may be that. You draw the graph first of all. Then take a point from codomain, draw a line horizontal to it. Draw a line horizontal to it. If the line intersects the graph more than once, then it is a onto function. Otherwise, it is into function. Okay, na? Right. I hope that you understand this graphical approach. Then let us go for next type of function, that is bijection. Okay, na? Let us check whether it is what is a bijection. So clearly bijection means injection plus surjection. Okay, a function which is both injection and surjection, that is both 1 1 and onto, then it is called a bijection. Bi means two, bijection means it is the function should satisfy both the properties of 1 1 function and onto function. Okay, right. Given a function, how to check that is a bijection or not. Okay, so let us see two examples. Okay, right. So f is a function from R to R, f of x is equal to x square. Let us take another function, f is a function from R to R, f of x is equal to x cube. Let us check whether these two functions are onto functions or not. Okay, let us see that the graph of, so this is y is equal to x square. Okay, now, so clearly now here to check the function is a bijection or not, here also you have to concentrate on the codomain. Concentrate on the codomain. Therefore, so any point in the codomain. Codomain here what? Set of real numbers. Set of real numbers. Here set of real numbers I have taken R. Set of real numbers I have taken R. Therefore, any codomain or if you draw a line, if should intersect at least at one point, it should intersect the graph at least one point, then we say that at least one point. At least one point, then it is we say that is an bijection. But here it is not intersecting. Now I am taking here y value here, why? Because the codomain is R, that means negative y values are also there. Here negative values if I have taken, if you draw a line, horizontal line, it is not at all intersecting, therefore it is not a bijection. Okay, right. Now coming to see here the graph, this is a, so this is a y is equal to x cube, y is equal to x cube graph. So draw a line, that means a codomain is set of real numbers. Codomain is set of real numbers. You draw the graph, any line parallel to x-axis. So it is intersecting at least one point or not, at least one point, then that function is a bijection. That the thing is in the both the say we have to take the point from the codomain. Okay, now, right. I hope that you understand this concept. Okay, now, so let us go for next problem. Welcome to this constant function and identity function, right? Constant function. So the constant function is, let us give me one example. Let us set a, b and f is a function from a to b. Let us take a contains the elements 1, 2, 3, 4, 5 and b contains the element 7, 8, 9, 10, 11. That is 1 is mapped onto 8. Let us take 2 is mapped onto 8. 3 is mapped onto 8, 4 is mapped onto 8, 5 is mapped onto 8, all 8, only single element. That means f of x is equal to some c for all x belongs to domain. Okay, now for all x belongs to domain, then f is called a constant function. Okay, now, right? Or for all domain, for all the elements in the domain, there is one and only one image, that is c. Here c is not, here 8 maybe 9 maybe 10 maybe 11, but only one image, that is called a constant function. From this one conclusion we can get is, what is the range of a constant function? This is a singleton set. In the range you will get only one element, either 5 or 6 or 7, 8, 9, 10, whatever may be, only one element you will get. So this is called constant function. Okay. Given a function, so whatever may be the constant function, its graph is always, see here, x-axis, y-axis. For example, see, 8 is the image of 1, that means 1 comma 8. So this is a 1 comma 8, 2 comma 8, 3 comma 8, 4 comma 8. If it is minus 1 comma 8, 2 comma 8, that means what? The line will be parallel to x-axis. The graph of every constant function is parallel to x-axis. It may be either above the x-axis or maybe below the x-axis. Understand, the graph of the constant function is always parallel to x-axis. That's all. Why? Because For everything is image is same, maybe same, y value is same, y value. For different x values, y value is same. That means obviously the line should parallel, you will get a straight line, and if the line should parallel to x-axis. Clear? If the graph of the function, it should be a straight line and the line should be a horizontal line. That's all. Then we can clearly say that that function is a constant function. Okay, now coming to identity function. Here the specialty of the identity function is it is defined from A to A. Here domain is A, codomain is A, range is also A. So far we have taken two different sets, A and B, two different sets we have taken. But for identity function is a special type of function in which it is defined on set A, and every element of A is the image of itself. That means, let us give me one example. A only. Function is I. Generally, we denote the identity function with I. If it is A to A, IA. If it is B to B, IB, like that. Here the elements are 1, 2, 3, 4. Here also elements are 1, 2, 3, 4. 1 is mapped onto 1, 2 is mapped onto 2, 3 is mapped onto 3, 4 is mapped onto 4. Every number is mapped onto itself. So the specialty of this function is domain is A, codomain is A, range is also A. That means f of x is equal to x for all x belongs to A. For all x belongs to A. So what is the image of 1? 1. Image of 2? 2. Now let us see the graph of this function. Let us see the graph of this function. X-axis, y-axis. So now see here, what is the image of 1? 1. What is the image of 0? 0. Image of 1? 1, 1. 2, 2, 3, 3, 4, 4. Minus 1, minus 1. Minus 2, minus 3, minus 2. So if you join this, you will get a line passing through origin, making a 45 degrees with the x-axis in the positive direction. Okay. So if any graph of the identity function is a straight line passing through origin, lies in the first and fourth quadrants, and making 45 degrees with the x-axis. Understand? Any line. Why? Because clearly it is saying 1, 1. So in this line, the x coordinates and y coordinates are equal in size, equal. That means minus 1 comma minus 1. This is minus 2 comma minus 2, minus 3 comma minus 3, minus 4 minus 1, 0 comma 0, 1 comma 1, 2 comma 2, 3 comma 3, 4 comma 4. Understand? So the constant function graph is parallel to x-axis. Identity function is graph is a line passing through origin, lies in first and third quadrants, and making 45 degrees with x-axis. So these are the graphs of constant function and identity function. Okay. So let us see the even function and odd function. Okay now. So dear students, let us see that even and odd functions together. So let us define like this. F is a function from A to R, where A is a subset of real numbers. Subset are equal to real numbers. A is the domain, R is a set of real numbers. Then the function is said to be even function if f of minus x is equal to x for all x belongs to real numbers. F of minus x is equal to x for all x belongs to real numbers. Okay, that means what? For example, f of x square mod x cos x. All these functions are even function. Why? Because in place of general definition, in place of x, substitute minus x whole square, x square. Again you are getting f of x, this is. F of minus x is equal to f of x. Same, again you are getting the same thing. Modulus of minus x is modulus of x. Cos of minus x is cos x. If you observe the graphs of the even function, for example, see the first graph, y is equal to x square graph. This is y is equal to x square graph. This is a y is equal to mod x graph. Y is equal to mod x graph. So this is equal to y is equal to cos x graph. So this is equal to 1, this is 0, this is pi by 2. If you observe, all this is y axis, this is x axis. y-axis, x-axis, y-axis. All these graphs are symmetric about y-axis. So this is a y-axis symmetric about. Symmetric nature means what? Whatever may be the graph, shape of the graph which is on the left side and right side, both are same. Both are same. This and this both are same. This is and this is. So all graphs are symmetric about y-axis. Symmetric about y-axis. All graphs are all even functions. All even functions. The graphs are, the curves are symmetric about y-axis. And one more conclusion point what you have to get is, if x comma y is a point on the graph of even one point, then immediately we can say that its opposite point is minus x comma y. This is also a conclusion we can get. If x comma y is a one point, definitely minus x comma y is also a point on that graph. So these topics will be very, very useful to solve your JEE mains examination. Here also, if x comma y is one point, opposite minus x comma y is also a point on that curve. This is a conclusion we have to get. So it is a even function. The graphs of even functions are symmetric about y-axis. Okay, both y-axis, positive or negative. Okay, now coming to odd function. So coming to odd function. So here also same, f from a to r, a is subset r equal to r, then f of minus x is equal to minus x. F of minus x is equal to minus f of x. Then such type of functions are called odd functions. The best examples are f of x is equal to x cube sin x, f of x cube sin x. These graphs are best examples of odd functions. Why? In place of x put minus x whole cube, minus x cube, that is minus f of x. Sin of minus x is minus sin x, that is minus f of x. Now observe the graph of f of x cube and sin x. If you observe the graph here, so this is a graph of, so this is y is equal to x cube graph, y is equal to x cube graph. This is called symmetric about origin. Symmetric about origin. That means what? Origin and with respect to the quadrants. Quadrants are also symmetric. That means what? With respect to origin, whatever may be the graph lies here, same graph will be in the opposite direction. This is called symmetric about origin. Observe the sin x graph. So this is equal to sin 0. This is a pi by 2. This is pi. This is 0. 1, sorry. So this is a pi by 2, again pi. Again it will come like this. Observe here the graph. Symmetric about origin. Symmetric about origin. Whatever may be the lies above the origin, and the same thing will be lies in the below the origin also. That is the nature of the curve of the odd functions. Okay, now from this we can say that if x comma y is a point on a curve, then automatically minus x comma minus y is also a point on the curve. Okay, now right. Same here also, if x comma y, so the same point minus x comma minus y is also lies on the same curve. That means even function graph is symmetric about y-axis. Odd function is symmetric about origin. Origin means what? Whatever may be the lies above the x-axis, the same graph will be lies below the x-axis, but it is symmetric. This type of nature it will be there. Okay. So dear students, I will hope that you understand this concept. Okay, now dear students, let me conclude this session, okay, by maximum this one onto bijection function. So here one function is at most one point. What is that meaning of that? Means if you draw a line parallel to x-axis, if you draw a line, that line should intersect the curve at most one point. Maximum one point only, at most one point. That means if sometimes if it is not even not intersect also, remember that at most one point means maximum one point. That means if sometimes if even though it is not intersect, then also it is a even function only, sorry, 1 function only. Coming to onto function, for onto function and bijection, you have to take a point from codomain. Be remember that. So here, so total domain, so sorry, total codomain, anywhere you can take, anywhere you can take. But the here the thing is, you have to take a point from codomain. It should intersect the graph, the line parallel to x-axis, horizontal line, at least 1 point, at least 1 point. That means what? If you draw, see here, I have taken the function from r to 0 to infinity. Here codomain is 0 to infinity, that means 0 to plus infinity, that is y-axis. I have taken 1 point, I have drawn a horizontal line. It intersects the graph at 2 points, but he is saying at least 1 point. Yes, it is also an onto function. But the thing is here, observe here, at only 1 point, it is only 1 point. Here also you have to take the point from the codomain also. If you draw a line, then this is a f of x is equal to x cube graph. Then it intersects, this should intersect at only 1 point, only 1 point. Then it is a bijection. Observe here, at most 1 point, only 1 point. Try to understand the difference. Here at most 1 point means there are certain curves in which if you draw a line parallel to x-axis, even though it does not intersect the curve, then also it is an even function. It is an 1 function. But here must and should, it should intersect at only 1 point. Only 1 point. Try to understand. It is at most 1 point. It is a only 1 point. The thing is here you can take the point from anywhere in the codomain. But here you have to take the point from only from codomain. Here anywhere defined in the codomain, whatever may be the codomain, from that only you have to take. Okay, na? Right. So these are some examples from the 1 function, onto function, bijection. So dear students, I hope that today you approach the graphical definitions of this all these types of functions. Okay, na? So with some more concepts in the tomorrow's class, I will present before you. So until then, all the best.